Hi guys, this is Dr. Gonzalez here, and in this presentation we're going to be talking about sources of information. This is going to cover some of the information that was also covered in Psych 4370 under sources of information. So I'm going to try to make it quick and get you oriented for what you need to complete this week's assignments. So understanding where your sources of information come from is very important in not only scientific thinking, but the development of a research study. So psychology is going to use empirical research to confront those beliefs that we're getting ready to test. And that's important because it's not going to rely on intuition or your own view of how things should be. So let's talk about an example with the celebrity versus scientific claims with vaccines. So some of you may have heard of the actor Jenny McCarthy. She has a son that has autism, and she claims the vaccine caused it. Her claim is based on her personal experience, and it's an anecdotal report, not scientific evidence. So I just want to reassure you that there has been extensive research in both the scientific and medical communities, including very large epidemiological studies that have repeatedly shown there is not a causal link between vaccines and autism, and we'll talk more about that in a little while when we talk about credibility. So why, as researchers, is our scientific research more reliable? Well, first, it uses methods that are controlled. We're going to use large samples that try to get at the population in question, and our research is going to go through peer review before we publish it. Now, why is authority not always trustworthy? Even the best expert out there can spread misinformation if they don't have expertise in that scientific area. And so why should your personal stories not be considered evidence? Well, in general, your personal stories, intuition, experience, and anecdotes are driven by emotion. And they are very nice stories, but they are not generalizable, nor do they have scientific rigor. Personal beliefs tend to be based on your experience, like say you drank an herbal tea and you slept better that night. They may be based on intuition, something might just feel right. Or maybe an authority figure, like your mom or your grandmother told you something, like mom said tequila on the gums will help your baby when they're teething. In contrast, scientific conclusions are going to be based on empirical research. So that is a systemic way of observing, collecting data, and then analyzing that data using statistics. And good experiments are going to have comparison groups, controlled variables, and we can replicate them in order to prove their results again and again. So an example might be that yoga helps make you, it feels helpful to you, but a randomized controlled mindfulness trial might actually be a scientific way of studying how something like yoga could be helpful. Now, we mentioned earlier that personal experience doesn't have a comparison group, and I want to highlight that your personal experience and my personal experience in the same category of life may be very different. And there's no baseline with comparison for personal experience. Your personal experience may have been under the effect of confounding variables, which are outside factors that influence that outcome. And those make it impossible for us to truly determine causality between two variables. You need controlled conditions, and we can't attribute a change to the variable of interest if we don't have them. So if you go to therapy and you say, I feel better after therapy, it ignores the fact that you might have felt better without therapy. Time may have made whatever the issue was better. You don't know. A confound is going to be a third variable that is influencing both your independent and your dependent variable. So an example would be something like this. You started using a meditation app, and at the same time you started sleeping and exercising more. Soon you feel like your anxiety levels are lower. So how do you know if it was the app? How do you know it wasn't the sleep or the exercising, or maybe all three? The truth is you don't have any true way of knowing because some of those may be confounding variables. Now, experiments are the gold standard for helping us establish causality. We want to see if Changing one variable while holding all the other variables constant lets us produce a significant result that we can contribute back to the independent variable. Having control groups there help us isolate and truly identify if that IV was having a true causation relationship. Randomly assigning our participants also helps us control for those differences. So when you control confounds, you get a stronger, more trustworthy conclusion. So how do you truly control for confounds? First, you're going to randomly assign those participants to either an experimental group using that meditation app, and you're going to have a control group that doesn't use the app. Both groups are going to be monitored for things like their sleep, diet, and exercise. We want to make sure those don't dramatically change because those are confounds. We also want to have a baseline. We want to measure anxiety levels before and after the trial, and then we can more confidently attribute a difference in your anxiety to the app and not one of the confounds. Research is also probabilistic, and that means we're looking for patterns observed over many different people and not an absolute rule that applies to everyone. Probabilistic reasoning means you're talking about the likelihood of something happening, not a certainty. So that means even if everything is held true on average, it might not necessarily be true for every person or every situation. Now, some people reject research findings if they have an exception to the rule. So maybe they have a cousin who smoked and is 90 years old and hasn't died. That's great. That's an exception to the rule because science doesn't aim for certainty in all situations. It's looking for trends. Research conclusions aren't just going to be invalidated because one person had a different experience. Science makes statements such as this is likely to happen for most people, or on average, X causes Y. So think about this situation. You've got a researcher who wants to conduct an experiment about getting sleep before an exam, and they're looking at exam performance in a group of students. So that doesn't mean that every student who got 8 hours of sleep is going to ace that test. And it doesn't also mean that every tired student is going to fail. What it does mean is that across the group at large, better sleep is going to be statistically associated with better scores. So just because there's an exception, it doesn't negate the general pattern. Now, humans have to deal with bias all the time, and we often rely on our intuition. Psychological research has shown to us that intuition is often flawed due to several different kinds of bias. First, you have the availability heuristic, and that's where we overestimate the likelihood of some event that's really easy for us to recall. So if you think about shark attacks, people think they're more common than they actually are. They maybe also assume that someone is a psychologist just because they're insightful, and that's called the representative heuristic. And then you have the present bias, which means every time I wear my lucky socks, my team wins. Well, that's just a coincidence. Motivation biases come from your desire, preference, or emotional investment in something that you want to believe. So examples are like, I knew energy drinks worked. Look how well focused I was after I took that Red Bull. Well, that's a confirmation bias. You sought out and remembered information that confirmed your belief. We also tend to cherry pick evidence. That happens when we pick things that support what we're saying and we ignore things that are contradictory. And we also have what's called a bias blind spot. What that means is we think other people are biased, but oh, it couldn't happen to me. I'm an objective person. Intuition feels convincing because it's immediate, and not only that, it's emotionally satisfying. But those two things don't make something correct. So even a well-meaning person can make a very serious error in judgment. What you want to do is contrast yourself and be a scientific reasoner. So a person who is not a scientific reasoner is an intuitive thinker. Someone who is an intuitive thinker is going to rely on their personal experience and gut feeling. They're going to be influenced by cognitive and motivational biases. They might look for patterns even though they don't exist. They're going to trust anecdotes and good stories. And they're not conscious of how confounding variables or a base rate can affect things. You want to be a scientific reasoner. This is diametrically opposed to an intuitive thinker. You're going to use systematic observation and experimentation, including comparison groups that allow you to look at differences. You're going to take into consideration the totality of evidence, not just an individual case. You're going to recognize that confounds exist, and you're going to work in your experimental design to control for those. And you're going to acknowledge that bias exists, and you're going to actively try to minimize that bias. So here's an example. A researcher tests a gratitude journal intervention by doing the following. So a gratitude journal is a journal where you give thanks and reflect for certain things that are in your life. And it's supposed to help you have a better mood and lessen anxiety and depression. So if you really wanted to test this in an experimental way, you would have two groups, one that uses the journal and one that doesn't, and you would randomly assign your participants to that group or the other. You're going to measure their mood changes using validated and reliable instruments and scales. And then you're going to make sure that you've controlled for confounds by ensuring your groups are similar in other ways. Now, people tend to trust scientific authority, or they trust people that they view as an authority. But not all authorities are credible, and not all authorities are accurate. And even a credible expert can be wrong sometimes. So for this reason, psychology and science in general are more broad in that we evaluate evidence and not just who the evidence was from. So an authority is a perceived person or a person that is perceived to have expertise in an experience or a domain. So professors might be seen as authorities in education, doctors as authority in medicine and research, therapists as authorities in evidence-based practices, public figures and celebrities, they can be authorities in anything that we perceive them as, and government agencies also can be an authority. So you have to be able to determine when an authority is trustworthy. So a credible authority in science and psychology is someone who has the relevant education and experience, has published in peer-reviewed journals their original research, and their research has conclusions that are based on empirical evidence. They're going to also acknowledge limitations of their research, and they're going to avoid overgeneralizing to other situations where their research may or may not apply. When does authority become a problematic person? Well, that can happen when experts become biased, when they overstate their conclusions, or if they promote their ideas without having solid evidence. Maybe they're getting a financial incentive, or it's just part of their ideology. So what's even worse than that is you can have non-experts claim expertise, and this is often done in popular media. Now here's an example that is not related to popular media, but Andrew Wakefield was a physician, and he's from the United Kingdom, and he published a fraudulent study linking vaccines to autism in 1998. I remember reading this article when it came out, and I remember thinking, we've kicked it. We have figured out what causes autism. I was an undergraduate at the time, and I had not even taken my first research methods course nor a statistics course when I came up with that conclusion after reading that article. And boy, was I wrong, and not only was I wrong, so was he. So he was discredited because the foundations of his study were extremely bad. He had a very small N. He only had 5 or 6 participants in his study. And not only that, he had his own vaccine that he wanted people to use. So in order to position himself in a place where he could gain from a financial perspective, he sought to discredit vaccine hesitancy in the current vaccine by talking about mercury and thimerosal and all kinds of things that have caused consequences even today. So that was a clear case of someone's authority that was being misused. It was also a case of the public, myself included, accepting a claim without being able to evaluate the evidence. And the media grabbed a hold of this article and amplified a very flawed message. Now, scientists do things differently. A good scientist is going to place their trust in data, not titles. They're going to thoroughly evaluate claims by going through the peer review process, replicating other experiments, and using quality research methodology. When they make a claim, they're going to back it up with solid evidence. So even a person who wins a Nobel Prize in chemistry or biology has to be able to back up their claim with solid evidence. I've already mentioned once in one of the previous presentations, you need to be a good consumer of research. Always ask yourself these questions. What's the claim in the situation? What is their evidence? And has this been peer-reviewed and replicated? So one of the things that you're going to need to learn how to do as a researcher is finding and reading research relevant to your particular field or domain, right? You need to know how to find that research, read it, and evaluate it. And that's a critical skill, not only to have in the academic setting, but also when you get out into the world. So there's a process you use where you gather credible information that you're going to use, whether it be an assignment or a research paper or just to make an informed decision. So scientific sources are going to be sources that are written by researchers for other researchers or for students in the field. So in psychology, that's going to include things like peer-reviewed journal articles, chapters that come in edited academic books, and reports from reputable scientific organizations like the APA, the NIH, or the World Health Organization. And all of those sources are generally reviewed for accuracy. They're going to cite or publish original research, and they're going to be grounded in both theory and evidence. There are databases and search tools that you can use to find those sources. PSYC Info is a psychology-specific database, and it's the most reliable for finding things that have to do with psychology. You can also use Google Scholar. It's free and broad, but you've got to be a little more careful and make sure you filter carefully to get peer-reviewed journal articles. PubMed is a search tool that relies on the life sciences and health-related psychology. JSTOR and Science Direct, those are for older articles and sometimes more interdisciplinary topics. And most universities have some sort of library search portal that will offer you a selection of journals and ebooks that they have subscribed to for your use at that university. Now, once you've selected your articles, you're going to need to be able to read them in a way that is not overwhelming. First, you're going to focus on the abstract, which provides a quick summary of what that research was about, including the purpose and methods and the overall findings. The introduction is a section where the researcher presents a review of the literature and tells you what we already know, and it presents what they're going to test, including the hypothesis. The method section tells you how the study was done. That's the who, what, where, when, how. Results presents the data and the statistical outcomes, and it usually includes things like graphs and tables. And discussion is where they interpret what they found. And they also note their limitations and also future areas for other research. Now, not all sources are the same. You've got to be very careful when you use things like popular press articles, wikis and blogs, and the wonderful world of videos like YouTube summaries and TikTok content. Sometimes those things may oversimplify something, they may misinterpret results, or they may just lack evidence whatsoever. You need to be able to take a claim and trace it back to a peer-reviewed journal article that presents original research whenever that's possible. Now, for your coursework and research, especially for this course, you should rely on peer-reviewed journal articles, possibly books written by credentialed experts, and maybe a scientific organization's publications. Primarily, though, we're going to focus on peer-reviewed journal articles. Now, less scholarly sources do have a purpose. They usually serve for orienting you for the purpose of a general background or to allow you to look at the public's perceptions of a topic. They're not going to be used to support scientific claims. Now, how do you know something is an empirical article? Well, it's going to present the results of an original research study. And an original research study collects and analyzes data, and it follows a structure. The MRAD structure is the most common way of describing this, and that's the introduction, method, results, and discussion. It's going to report how the data were collected. Was it an experiment, a survey, an observation? It's going to include statistical analysis, and it's going to have interpretations of that. So earlier we talked about mindfulness on anxiety in college students using a randomized controlled trial. And that right there gives it away to me that this is more than likely empirical because it's randomized and controlled. And it also mentions the word trial, which kind of conjures up clinical trials for me. So I know that there's things that are implied by that, but I would still need to do my due diligence and make sure this was a valid research source. Now, review articles also serve their place. These summarize and synthesize findings across multiple studies on a particular topic. And this really allows you, the researcher, to understand what the research community knows right now and what they don't know about an area or a topic. They don't collect original data, but they do review previous empirical studies. And they're great for identifying trends, gaps, and future directions. So an example would be an article summarizing 50 studies on stress reduction techniques in adolescence. Again, it's not going to present new information about stress reduction techniques. It's going to summarize what's already been done about that. Peer review is a process that we use in psychology and in the publishing community. And it's a quality control process where you have a group of experts in a field that are going to review a manuscript before it's decided to publish in an academic journal. And their goals are to ensure that that research was accurate, methodologically sound, and relevant. They also want to catch errors, oversights, or flawed reasoning on the part of the researcher. And in general, peer review serves to improve the quality and clarity of the paper through the revision process. So they may review the manuscript, and they may kick it back to you, the researcher, and say, well, we'll accept this, but we want to accept it with revisions. We feel like you need to put more into this section or another section or whatever. And if you want it published, you're going to follow their recommendations. Now, the peer review process goes like this. You submit your paper to a journal, and there's an editorial check. Usually the journal editor is going to decide whether it's a good fit. If not, it may get kicked back right there. But if it's deemed something that may fit, it goes to a peer review panel. Reviewers are assigned to it. These are usually 2 or 3 expert psychologists in that field, and they review your manuscript. They're going to provide feedback and evaluate your design, your methods, your statistical methods, your logical consistency, and whether or not the findings you have are even relevant to the field. They're going to make a decision. They can accept it with minor or major revisions. They could reject it, or they could say revise and resubmit. And ideally, that process is anonymous. It's either single or double blinded. And that's to minimize bias. So what that means is you don't know who's reviewing your article, and they don't know whose article they are reviewing. Now, the peer review process is essential in psychology because it helps protect us against flawed studies being accepted as the truth. Hopefully we would catch in that process that the study was flawed and prevent that from happening before publishing. It's also going to ensure that researchers are contributing meaningfully to the field and they're not just conducting, bull research out there and getting it published. And it's also going to help filter out work that is unethical or lacks statistical rigor or possibly can't even be replicated. Peer review also helps prevent fraudulent data from making it out there into the world, and that's not always easy to determine. There are cases out there of people in the last 10 years that have published things using fraudulent data, and it was only way after the publishing of their studies that it was ever brought up. It's also going to help us control pseudoscience, which is, things that are on the border of being science, but maybe they lack that empirical process that we were looking for earlier. It's also going to help us prevent the overgeneralization of conclusions or poorly justified causal claims. Remember, if we're going to make a causal claim, we've got to meet a set of criteria for it to be a cause and effect relationship. We're going to need some experiments to be done. Now, peer review process is limited. It's not perfect. There are still flawed studies that get published. It's also a process that can be slow or biased. It takes time for these manuscripts to be reviewed, and that's a little hesitant. It's a little annoying, I can see. But it's far more reliable than just allowing unchecked claims to run rampant out there in the scientific community. Another resource that may be valuable in psychology is a book. It can be valuable when it's written by experts in the field, or when it's published by an academic or university press, or if it's based on or references a lot of peer-reviewed research. Now, there are a lot of other books out there that don't meet those criteria, and those would not be considered good sources to use in a class or a paper or designing a research study. You need to make sure that books serve their mindfulness with the type of book you're dealing with. So a lot of books are great for historical context, theoretical frameworks, or background knowledge. So if you want to know more about a topic, a book might help you. But that book's not going to tell you about the research that's been done about that topic. Books also serve to help deepen an understanding of something that may not be covered in journal articles. So maybe it's something that we have not completely understood yet, and new aspects of it are out there, but it hasn't been researched yet. So you might find information about it in a book, but you're not going to find any peer-reviewed articles presenting original research in a book. And books are not really the best source for finding what is going on right now in the empirical world of your topic. That kind of data, that empirical finding, is going to be in a published journal first. Some other sources that may or may not be useful, depending on the kind of research you're doing, are government and institutional reports. Things that come out of the CDC may have some useful data when it comes to public health or behavior, education, or development. Sometimes we go to dissertations or theses, which are original research that's been conducted by a graduate student. But if they haven't published those findings, it's likely not going to be considered peer-reviewed. And then conference proceedings might present new research at an academic conference, and they're usually good for looking forward at what's coming up next. Now, what sources do you need to avoid altogether or use cautiously? First, be careful around self-published books or pop psychology titles. So things like The Secret or self-help books that don't cite any published journal articles or any sort of empirical data. So you also want to verify the credentials of that author, the publisher, and their reputation, and whether or not the claims they're making in that book are even supported by any sort of empirical data at all. Be careful with popular media and news articles. A lot of times those are easy to understand and they're quick to access. But it's very easy for the authors of those sorts of articles and news media to misrepresent findings. They may lack a lot of detail, and they may actually cherry pick results or omit any limitations that actually exist. So anytime you find something in one of those particular kinds of sources, you want to trace the article or trace back to whatever original study that they're quoting from, and make sure to link it and mention the journal name and or the author. Be careful with wikis. Wikis are great for getting an introductory reading or a definition. They include citations, which can sometimes help you find quality sources. But remember, wikis and content like that can be edited by anyone, so it can always include error or biases. They're best to be used as a sort of starting point, but not as a source that you want to cite. Be careful with books that you find from a retail shelf or from Amazon, YouTube videos, social media posts, or any other video platform like TikTok. Just be careful. Those are usually considered to be weak sources. Now, before you use one of those questionable sources, you need to ask yourself the following questions. Is the person who wrote this an expert? Do they cite peer-reviewed research? Can you actually find the original study this is based on? Does it seem like they're making a too simple of a claim, or they feel too confident in what they're saying? And does the actual content there acknowledge limitations or exceptions to whatever they're stating? Now, let's talk about a literature review, because that's going to be one of the things you're going to do in this week's assignments. You're going to come up with a short literature review for a research question. So a literature review is a critical summary and synthesis of what's already been done on a particular topic. It's not going to present new data. It's going to organize and evaluate the previous things that have been found. It's going to look for patterns or trends in the research. And at the same time, it's going to highlight gaps and inconsistencies, because that's where your new research question and hypotheses is going to come from. A lit review helps you understand the current state of the body of knowledge about a topic. It helps prevent duplication of previous work. I don't want you to worry about that with your paper in this class, because I'm not expecting you to propose a research study that hasn't been done before. It's okay if you do that for this class, but in the real research world, we don't want to duplicate stuff that's already been done before unless we're intentionally replicating something. Literature reviews help you justify why new research needs to be conducted. It helps clarify a theoretical framework that already exists. And it provides support for your research question and hypothesis. So almost every published empirical study has a literature review in that introduction section that's going to tell all of the research that's been done on a particular topic and highlighting the need for whatever research question is that it's proposing now. A good literature review is going to have a thesis statement and an introduction. So it's going to clearly define the topic of research that the question is dealing with and the scope. And it's going to state the purpose or the main focus of the review. It's going to also summarize those key studies out there that are contributing to the body of knowledge at this point in time. It's going to talk about what was studied, who the participants were, and what the methods and findings were. And so sometimes your literature review might include classical foundation studies or more recent developments in that research field. A good literature review provides a critical evaluation and synthesis of the research. So it shows how studies are connected with each other or how they differ. It highlights strengths and limitations of previous research. And it tends to group findings by theme or theory or methodology. It also has a conclusion where it summarizes the state of the literature and highlights the gaps, contradictions, or unanswered questions that still exist. And that leads you in a proposal directly to your research question and idea that you're presenting. And a literature review, like we're going to do in this class, has a full APA-style citation and reference section for all of the sources that were used. So you're going to write a research proposal paper in this class. It's one of the major components of your final grade. This week, you're going to need to select a research question from the list of approved questions in Canvas. Now, all of these questions have been examined by me over the past year and are designed to help you write a research proposal using an experimental design. So I want you to go in and look at that list of questions, and I want you to pick one. And after you've picked one of those questions, I want you to write a short literature review. So that's going to require you to do a lit search using those databases that were suggested earlier in the video. You're going to need to find 6 empirical peer-reviewed research articles that are related to your chosen topic. For each one of those articles, you're going to write a short paragraph, at least 6 sentences, that summarizes that article. You're going to tell me how that article is relevant to your research topic and the question, and it's going to be written using a template that I'm going to provide you in Canvas. You're also going to include an APA citation for each article. You simply need to follow the template. And I'm going to include a review video on how to do your assignments for the week, so there will be more information about this in that video. You're going to include an APA citation for the article. If you follow the template, it should be very easy. And then you're going to submit your lit review along with one example of the articles that you found in PDF form into Canvas. Now, don't forget that be sure that your literature search is organized, clearly written, and it demonstrates that you understand how these articles are going to inform your research question and topic. Go back to Canvas later on and look for the instruction page, the instruction video, and the template. And there is a rubric, but it's not on the next page here, so ignore that, but I will include that in Canvas. How do you find the articles? I would suggest looking at PsycInfo and Google Scholar and using terms like stress and coping in college students if you're wanting to look at articles that were peer-reviewed about stress and coping and in your population of college students. That is one thing you're going to have to do with your research question, is identify who your population is going to be. Basic APA formatting can be found in your APA style guide that you are required to purchase or access with this course. That style guide is going to help you, but you're going to need to use both in-text, Smith & Jones 2022 found, that's an in-text citation, and create a reference. You can go to Purdue OWL and use your APA manual as a guide, and I'll also try to include a few APA resources in Canvas. So if you have any questions, please email me. I'll be happy to set up a Zoom or actually Microsoft Teams appointment if you want to discuss your topic and your research question. Excuse me, it's getting late and I wanted to finish this video tonight, so I'm glad I did that. If you have any questions, please reach out, and I promise I will include another video with this module so that you know what's expected of you before you start writing. Take care, and I look forward to talking to you the next time. Bye-bye.